Starting with graphs. In this chapter, you will learn about another non-linear data structure after trees is called as graphs. This will be the last data structure we will cover before starting with sorting and searching algorithms. So last data structure, I can say the last advanced set of the data structure where we had an overlook of how we will implement JavaScript functionality. So this chapter will cover a considerable part of the wonderful applications of graphs. Since it is a vast topic, so we will first discuss about the graphs with the typical use cases, and then we will implement a graph in JavaScript functionality, and we will later on analyze what all the different type of functionalities are included in graph and how they can be implemented with the help of JavaScript. Since it is a wide topic, so it is like we would like to dive in this amazing world of graph. So starting with the first section, I would like to say graph, as it's mentioned over here, consists of a set of vertices and set of edges. Graph is an abstract model of a network structure. Graph consists of set of nodes, or that nodes can be called as the vertices, and they are connected with the help of edges. So learning about graphs is important because any binary relationship can be represented with the help of graph. Any social network, if there is a picture in your mind about the social network, say for example Facebook, Twitter and Google Plus, can be represented by a graph. So we can use graphs to represent roads, flights and various type of communications. So every graph has some set of vertices, as I mentioned. So vertices are nothing but the nodes, and these are connected with the help of the dashes, which are called as the edges. So that is a basic definition for a graph. The edges are defined as per the pair of the vertices. Say for vertex V1 and V2, so these are the two vertex. So where V1 and V2 are the two vertices, and that is connected with the help of an edge. A vertex can also have a weight, sometimes which is called as the cost. So these are certain terminologies for graphs. A graph whose pairs are ordered are called as the directed graph or just a digraph. When pairs are ordered in a directed graph, an arrow is drawn from one pair to the another pair. So let's have a look about the basic terminologies or the structure of a graph. I can start with even saying that it is nothing but a study of networks that has become great scientific hotbeds of this century. Through mathematicians and others have been studying networks for many hundreds of years. So recent developments in computer technology, say for example in social theory, as I mentioned about some social networking websites like LinkedIn, Facebook, Twitter, popularly called as the 6 degrees of separation, not to mention social media, but put a spotlight on study of networks. So that is basically done with the help of a graph. Graph consists of a set of vertices and set of edges. Think of a map of US state. Each town is connected with other towns via same road. So that can be a best example to understand. A map is a type of a graph where each town is a vertex and a road that connects two towns is called as an edge. If I want to go say from Mumbai to Pune, then I have a road with expressway, then that expressway can be considered as an edge. A vertex can also have a weight, which is called as a cost. So here, what is this cost all about, we'll understand in our upcoming chapters or the illustrations. A graph whose pairs are ordered are called as a directed graph or digraph, whereas a graph, when pairs are ordered in directed graph, an arrow is drawn from one pair to another pair. So what are directed graphs? So directed graphs indicate the flow of direction from one vertex to the another vertex. Consider, if you know the mathematics terminology, there is a concept called as scalar and vector. So scalar does not have any direction, it only has values in it. So if a directed graph is there, it is a vector which includes value, that is the cost, and also a direction of a node, say direction of edge, passing from one vertex to another vertex. So this is a basic understanding. So directed graph indicate the flow from vertex to vertex. A flow chart that indicates the direction of computations or computations in computer program is an example of directed graph. Moving on to the next functionality is understanding the directed graph. So this is my directed graph. So here you can see every node is represented with an arrow. Say for example, my A node has a representation with B and later with C and so on. So this kinds of these representations, you can see there is an arrow which is representing like where is the exact movement of a graph. So that is why it is called as a directed graph. On the other hand, if I say a graph is not ordered, it is called as the unordered graph or just a graph. For example, this is the unordered graph. I have the edges representation over here, but is it representing from 2 to 1 or 1 to 2? So there is no specific direction over here. So it is like just mentioning some values, or you can say the scalar values which are mentioned in the mathematics where we have the values but we don't have any specific direction. In such a scenario, we can say the graph is said to be an unordered graph. So this is the pictorial representation of an unordered graph. So let's understand some more terminologies about the graphs. Say for example, a path. A path is a sequence of vertices in graph such that all the vertices or the vertex in the path are connected with the help of an edges. So here, whatever you see in connection from 1 to 2 or 2 to 1 or say 1 to 5 or 5 to 1, so there is a path which is represented over here. So that is considered as an edge. So we can have the edge as connection between two nodes or two vertices. The length of the path is the number of edges from first vertex in the path till the last vertex. Say for example, this example in directed graph, here we have the typical representation of the direction. So here if I want to say I'm moving from say A to C, then in such a scenario, A to C transversal is like I'm traveling from A to B and then B to C. So my length would be 2 because I'm traveling 2 nodes or 2 vertices to reach this particular point. So it is like whatever number of nodes or vertices you are passing through to reach that destination can be considered as the length. A path can also consist of a vertex itself which is called as a loop. And loop is always said to be like it does not have any length because it starts from the same point and ends at the same point. So that is why loops have a length of 0. Then we have one more terminology in graph which is called as a cycle. Cycle is a path with at least one edge whose first and last vertices are same. A simple cycle can be said with no repeated edges or vertices for both directed and undirected graph. Undirected means unordered graph. Represents this one. Paths that repeat other vertices besides the last and the first vertices are called as general cycle. So now if a picture comes to you in your mind like two vertices are considered strongly connected if there is a path from first vertex to second vertex and so on. If the graph is directed graph, then all its vertices are strongly connected. Then the directed graph is considered as a strongly connected graph. Now there is always a question mark in your mind after understanding this complete data structure. Okay, now I got like graph is somewhat a representation like what we see in social networking kind of thing. There is a question mark also like is it a kind of a tree? A kind of tree, obvious, because if there is a graph in the hierarchical manner, then it will obviously show the representation like a tree. But you can also have one thing in your mind that there are certain real world use cases which are modeled by graphs. So graphs are used to model many different type of real world system. One example is the best example for graph is the traffic flow. The vertices represent the street intersections and the edges represent the streets. Weighted edges can be used to represent the speed limits or the number of lanes. Modelers can use the system to determine the best routes and the streets most likely which is used to suffer, for example, say traffic jams. Any type of transportation system can be modeled using graph. For example, an airline. So airline mode is also a best example for representing a graph. An airline can model its flight system using a graph. Each airport is a vertex and each flight from one vertex to another is an edge. A weighted edge can represent the cost of the flight from one airport to another. The distance from one airport to another depending upon what is to be modeled. Another best example for graph are nothing but the computer networks. So computer Networks include local area networks and much broader networks such as internet, and are frequently modeled with the help of graphs. The next example I can say which can be modeled in the graph is the computer or the consumer market. Vertices represent the institutes, and institutes are nothing but our vendors, and the nodes have the consumers in it. So these were the basic examples of our understanding for a graph. Next chapter will be a complete focus of implementation of a graph. So we understood what is graph, what are the nodes, what are vertices, and what are edges. Now we need to implement this particular graph. So first we will try to create a graph with JavaScript and print the values, or I can see the vertices of a graph with representation of the edges. So we will focus on that implementation first. So let's move on to our next chapter, which would be the implementation of a graph, and later we'll understand various kind of algorithms associated to it.